Okay, in lesson 8, we say that every rational number, every fraction, has a decimal expansion that falls into a repeating pattern. So rational numbers have a decimal that either terminates, that means it stops, it's finite, or it becomes a repeating pattern. So there's a pattern to the number. A natural question is now the converse. If a real number has an infinitely long decimal expansion with a repeating pattern, must it be rational? Okay, so we're going to start off by observing the effect of multiplying decimals by powers of 10. Consider this decimal. 1.234567 Okay, if we multiply it by 5 to the 10th, 10 to the 5th, we get the following. Okay, so then we would get, that's our original, we would get 10 to the 5th times 1.234567 which equals 10 to the 5th times 1 plus 2 to the 10th plus 3 to the 100th plus 4 to the 1,000th, plus 5 to the 10,000 plus 6 100,000 and so on and so on. So if we did this out, if we did I ran out of room, if we did the 7 and the 8, okay, what we would end up with is 100,000. This times this would be 100,000, 5 zeros, plus this times this would be 220,000, plus this times this would be 3,000. This times this would be 400. This times this would be 50. This times this would be 6. This times 7 over 1 million would be 7 over 10. And then this times 7 over 10 million would be 8 over 100. So if we added those all together, 123,456, 7/10, 8/100. So that's what we would get. So this is kind of combining rational numbers, repeating decimals, fractions with scientific notation. So we're kind of seeing how it all works together here. So we're going to jump right into example 1 here. It says there's a fraction with an infinite decimal expansion of 0.81 repeated. Find the fraction. So sometimes we will have a number like this and we have to use it in an equation or in arithmetic. We have to figure out adding something, subtracting something, multiplying something, dividing it with this number. And because it goes on and on and on forever, it is very difficult to do. So that is one reason we would want to find a fraction for it. Okay, so let's start by giving the decimal a name. So we're going to say that x equals 0.81 repeated, which is just 0.81818181 ... Goes on forever. Okay? So, like we did in the example before, we're going to multiply x by some powers of 10. So if we start with this, I'm going to change this. X equals 0.818181 repeated. If I multiply it by 10, both sides by 10, I'd get 10x equals 8.18118 repeated. Okay, if I multiply by 100, okay, if I multiply by 100, I get 81.818181 repeated. 1,000 will be 818.181818 repeated. So this is kind of what we're looking at. If we look at 100x, what do you notice over here? That the 81 is in front of the decimal, and then it starts again. Okay? So, I'm going to write this over here. If we have 100x equals 81.818181 repeated, okay, 100x equals 81 plus 0.818181 repeated. And we said that x was repeated, so 100x equals 81 plus x. Okay, so I just replaced this repeating part with the x we set up here. Okay, so now we have a fraction, an equation that we can work to solve for a variable. Okay, so I have 100x equals 81 plus x. Well, I want to get the x's on the same side, so this is plus x, so I'm going to subtract x from the left, or right, and the left. 100x minus x is 99x equals 81. Okay, now we want to get x by itself. These two are being multiplied, so the opposite of multiplication is division, so you would divide both sides by 99. X equals 81 over 99. And if we were to simplify that, okay, 9 goes into both of those. 9 goes into 81 9 times, and 9 goes into 99 11 times. So the decimal 0.81 repeated is 9 over 11 as a fraction. Okay, so if we look at this, the goal is to multiply by a power of 10 so that whatever we set x to equal is after the decimal, so that we can add them together. Okay, and we're going to do several of these together. Okay, so there is a fraction with an infinite decimal expansion of 0.123 repeated. Let x equal 0.123. Okay, and it says explain why looking at 1000x helps us find the fractional representation of x. Okay, so if we do 1000x, and then we'll write this out. So x equals 0.123 repeated. If I multiply both sides by 1000, I get 1000x equals, and I move this decimal over 1, 2, 3 places. 1, 2, 123.123, dot, 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 dot. So now, on this side, I have 1,000x, I don't know, equals 123 plus this part right here is this up here, plus x. Okay? So then, now I have an equation I can work with. I can subtract x on both sides. So, I'm actually 999x equals 123. We would divide both sides by 999. So x equals 123 over 999. And we can simplify that to become 9 goes in there. 3. We can divide the top and the bottom by 3, so we would get 41 over 333. So 0.123 repeated equals 41 over 333. Okay, and then I'm going to write this out. Multiplying both sides by 1,000, which is what we have here, we get a whole number followed by the repeating decimal. We can replace the repeating decimal with x and solve. Okay, and we actually answered B. B back here asks what is x as a fraction. So 0.123 repeated equals 41 over 333, which we found on the other page. Is this answer reasonable? So if we look at a calculator, okay, so if I take 41 and divided it by 333, we get 1, 2, 3, 1, 2, 3, or 0.123, 1, 2, 3, 1, 2, it stops, but I would imagine that it keeps going on if I turn it. Nope, it's not going to work. But it would keep going on. So, my answer is reasonable and correct. Period. So on number 2, it says there's a fraction with the decimal expansion of 0.4 repeated. Find the fraction and check your answer. Well, x is always going to be the infinite decimal. So x equals 0.44444. Now, if I were to multiply this, okay, if I were to take x equals 0.44 and multiply it by 10, okay, I would get 10x equals, the decimal would move over one place, because there's 1 0. It would be 4.444 repeated. So this would be 10x equals 4 plus 0.444 repeated. And now I can replace this with the original x. So 10x equals 4 plus x. I'm going to subtract x on both sides. 9x equals 4. They cancel. I divide both sides by 9. X equals 4 over 9. So I'm going to make sure that's right. 4 divided by 9 equals 0.4 repeated. So 0.4 repeated equals 4 over 9. Okay? So in example 2, okay, could it be that 2.138 repeated is also a fraction? Okay, so we want to see if there's a fraction that equals the infinite decimal 2.138 and that only the 8 is repeated. So only one digit repeats, but there are 3 places to the right of the decimal point. So we're going to let x equal 2.1238 repeated, and we're just going to multiply by various powers of 10. So x equals 2.13888888. And if I multiply by 10, I get 21.388888 repeated. If I multiply by 100, I get 213.8888. If I multiply by 1,000, I get 2138.8888. Well, none of the decimals over here are coming up with x. So, I don't know if it is helpful because we can't substitute in x. What if I asked a separate question? Is 0.8 repeated the decimal expansion of a fraction? If knowing that 0.8 is a fraction, would any of the questions we've had then be of use to us? Okay, so 0.8 we could easily repeated 0.8 repeated we could turn into a fraction, and as a fraction maybe it might be helpful in this situation where the 8 is repeated. Okay, so let's say, alright, that we're going to find 0.8. We're going to say y equals 0.8 repeated. So if I multiply both sides by 10, I get 10y equals 8.8, dot, dot, dot. So 10y equals 8 plus y. Subtract y on both sides. 9y equals 8. Divide by 9. Y equals 8/9. So then we can go back to this and plug in maybe for that. So let's say 100x equals 213.888. So 100x plus 200 equals 213 plus 8/9. So now it's going to get a little bit tricky where we have to bring in some common denominators. So my denominator here on the right, okay, is 9. So I want my denominator to be 9 for this number as well. So what I'm going to do here is I'm going to have 100x equals, and I'm going to change this to 213 over, and I'm going to make the denominator 9. So I'm going to also have to times the top by 9. Okay? So whenever I put a denominator, I have to multiply the top and the bottom by the same number, plus 8/9. So now when we do this, we would have 100x equals 213 times 9 plus 8. I just did all the way across in the numerator, and that's all over 9. So 100x equals, we would multiply this, 213 times 9 plus 8 equals 1925 over 9. Okay. So now I want to get rid of the 100x. So to get rid of 100x, we can divide it by 100, but it's going to be a fraction divided by 100, which the easiest way to do that is to just multiply by 1 over 100. So what happens is the 100 cancels on the left, and then we're able to multiply on the right. So we end up with x on the left, and then we have 1925 over 900. And if we were to simplify that, if we divide by 5, okay, if we divide by 5 again, okay, so both of these are evenly divisible by 25. 1925 divided by 25 is 77 over 900 divided by 25 is 36. Whew! So we can apply this technique to any infinite repeating decimal. Even if there is a delay before the repeating begins. So like, oh, you couldn't see that. There you go. So when I multiply these two canceled. Okay, and then I multiply 1925 times 1 and get 1925. 9 times 100 and get 900. These are both divisible by 25. It ends in 25 or it ends in 00. I know that because of that. So I divide both the top and the bottom by 25 and I get 77 over 36. So 2.138 repeated after, even when there is a while before it repeats, you can still change it to a fraction. So it's 76 over 70. Whoo, I cannot write today. 77 over 36. You can make it a fraction because there is a pattern, a repeating pattern. Okay. So we're going to go over and do exercises 2 and 3 on the next page. Okay, find a fraction equal to 16 or 1.2 or 6, 2, 3 repeated. The 2 and the 3 are repeated. So if I say that x equals 1.62323323 repeated. Okay, I would take that and I would multiply it by 10 so that the repeating part is what is left after the decimal. So 10x equals 16.232323. When I multiply by 10, it just moves the decimal over one place to the right. Okay? So now that I have this, okay, I'm going to find a fraction for the 2, 3 repeated. So y equals 0.232323. I need to move the decimal over 2 places. Okay, I want it to go over 2 places so that I'm left with the 2, 3 repeated at the end and a whole number on the left. So to move it over 2 places, I would multiply it by 100 because I need to move it over twice. So 100y equals 23.2323 repeated. I'm going to replace ny, so 100y equals 23 plus y. I'm going to replace it there. So I subtract y, 99y equals 23. I divide both sides by 99. Y equals 23 over 99. Okay, so now I know what I could substitute in here. Okay, so if I go back over to here, I could say, okay, I'm going to go here. 10x plus 16 equals, equals 16, and if I bring this over, plus 23 over 99. Okay, so now I have a denominator on the right, and I want them to all be the same denominator on the right side. I got to change them to fractions so I can work with it. So I have 10x equals 16 over, same denominator, 99. So to get this denominator, 99, I have to multiply the top and the bottom by 99. Okay, so 10x equals 16 times 99 plus 23 over 99. So 10x equals hold on. 16 times 99 plus 23, so 1607. Okay, so I would then multiply both sides by 1 over 10. It's the same as dividing by both sides by 10. Multiplying by 1 over 10 is the same as dividing by 10. So then the things on the 10s on the left would cancel. I would get x equals 1607 over 990. And that would be our answer, I believe. So 1607 divided by 990 is that 1.623232232. Imagine it would go on forever. So 1.623 repeated equals 1607 over 990. Okay. One more example down here on number 4. Okay, find the fraction equal to 2.960. So x equals 2.960, the 60 repeat. Okay, I want to get the 60 repeating in the decimal by itself, so I need to just move the decimal over one place. So that would be 10 multiplied by 10 equals 29.60 repeated, or 6060. So then I need to find a decimal for 0.60. So y equals 0.606060. I want to move the decimal this time over 2 places, 1, 2. So that would be 100. Y equals 60.606060. Okay. I have a y, so 100 y equals 60 plus y. because this number right here is this number right here. I'm going to subtract y on both sides. 99y equals 60. Divide both sides by 99. Y equals 60 over 99, which will simplify to 20 over 90, or 33. 3 goes into 60 20 times, and 3 goes into 99 33 times. So then I would take this and substitute it in for this decimal up here. So 10x equals 29 plus 20 over 33. And when you simplify, it's going to make the multiplication over here easier. Okay? So I want this to be 10x equals, and I got to get the same denominator, so I need 29 times 33 to give me a denominator of 33, plus 20 over 33. So 10x equals 29 times 33 plus 20 all over 33. So 10x equals 29 times 33 plus 20, 977 over 33. Now, I want to get rid of this 10x. The opposite of multiplication is normally division, but I have a fraction here. So I'm going to multiply both sides by the same number to get rid of the 10, and that would be multiply this side by 1 over 10 and multiply this side by 1 over 10. And I'm doing this because our number here is 10, so that's what I put in the denominator. If it were 1,000, it would be 1 over 1,000. Okay? So I'm using 10 because this is able to cancel each other out right here. So I'm left with, on the left side, x equals, I multiply 977 times 1 gives us 977. 33 times 10 is 330. And we would leave it at that. That is a large number, and we can double check that. 977 divided by 330 does equal the 2.960 repeated. The 60 repeats. So 2.960 repeated equals 977 over 330.